All right, I think we're going to start. I think it's kind of calmed down. Thank you everyone for coming to the second of two webinars. Thank you for joining myself, William, and Morgana, Islands Trust staff members. My name is Jillian, and I would like to begin by sharing that I live live in Esquimalt on Lekwungen Peoples Territories, also known as the Songhees and Esquimalt Nations. I've worked for Islands Trust for over 5 years in various roles, and tonight I'll be co-hosting and supporting the administration side of the webinar, along with my coworker Morgana, who's in the behind the scenes helping with the Q&A portion. Before I introduce our presenter for this evening, I would like to do a little bit of housekeeping. So this webinar is part of the Stewardship Education Program, where Islands Trust offers programming to help the public preserve and protect the islands in the Islands Trust area. This program has included mailing new property owners with information on land protection, stewardship tips, providing island-specific information on services, and this series, the co-hosting speaker series or webinars. So we are recording this webinar tonight, so we'll be able to post it on the website. So others will be able to view it, or you can watch it again if you want to go back to a section of the webinar. And while William presents, you may ask questions anytime during the presentation by using the Q&A function at the bottom of your Zoom box. You can, if you're having any issues or you're calling by phone, we'd recommend emailing communications at islandstrust.bc.ca, and Morgana will be able to gather your questions. Of course, we're encouraging you to ask questions through the Q&A function, just because it's a little easier on the behind the scenes here. We advise that you ask general questions on the topic, as staff will not be answering any questions in regards to individual local trust committee applications. And we may paraphrase your question or slightly alter it and making it general. Questions arising from the webinar will be posted on the website with their answers as best as possible. And I'm just going to share my screen and show, if I can do this real quick. Share my screen, number one. So hopefully, yeah, you should be able to see a web page, the Islands Trust website, Stewardship Education. So where you find this is the under programs, Stewardship Education page, and this is where all the webinar links are. So you'll see tonight's webinar, maybe you signed up from here. And then 3 weeks ago, we had another, this is 3 weeks ago webinar, and this is tonight's webinar. So you can find the recording from last webinar as well. So you can come here and find some more information about the program. And yeah, that's all my housekeeping. So I'm going to pass it over to William to start. Just gonna stop sharing the screen. There we go.
Great. Thanks, Jillian. I'm going to share my screen right away here. You can see my screen?
Yeah, you can.
Okay. Not showing me my video in the meeting host section, but that's fine. Okay. Thank you, everyone, and good evening. Thank you for taking time out of your schedule to join us for a webinar presentation and following question and answer on groundwater in the Islands Trust area. This is a topic that is near and dear to me. I'm a hydrogeologist by trade. That is my first degree. I have a degree in geology from the University of Alberta, and when I studied there, I focused in hydrogeology, which is the study of groundwater. And yeah, and then over the course of my career, I got more interested in hydrology and how groundwater relates to how watersheds function. Yeah, I'm the senior freshwater specialist here at the Islands Trust, and I'm going into my 7th year with the trust. Yeah, I think I'll leave it at that for right now. The I would like to say that the vision and the purpose in which I undertake my work at the Islands Trust and how the organization is rallying around the topic of freshwater and groundwater is deeply set in our object, the object of the trust, and it's truly to preserve and protect the Islands Trust area. And all of this work is in cooperation with our partners, and there's many partners in the regional districts, with the province, First Nation partners, local community groups, residents of the Islands Trust area, and it's really the driving force behind a lot of the work that we're doing here. Oops. I would like to say that I'm reaching you from my home on Salt Spring Island, and in the traditional territories of Coast Salish people. And I said this last time in my last webinar, but again, I had a chance to visit Wachum this week, which is in Bergwan Bay, and it's a very special place. And since time immemorial, Wachum has been and continues to be a vital source for local First Nations, shellfish and plants and medicine. And it serves as a significant landscape for cultural and ceremonial purposes to this day. And I'm very humbled and honored to be working in these lands, and I'm forever indebted to continue the work to protect freshwater resources. To follow up on our last webinar we had last month, the majority of this work, well, all of this work that will be speaking to today with respect to groundwater is embedded within the Islands Trust Freshwater Sustainability Strategy, which was released in 2021. And this is a strategy that was developed by the Islands Trust and was championed by the Regional Planning Committee. And the overall purpose of the freshwater strategy is to have freshwater sustainability as a key lens in which Islands Trust undertakes land use decisions and advocacy. Islands Trust, through the strategy, Islands Trust continues to support research and advocate for water literacy and provide open public access to knowledge about freshwater. And this is one of the examples of ways that in which our organization can share knowledge about freshwater. Okay, so we'll just jump right into it. A little bit of just structure of my presentation here. It's almost 7:15. My presentation should be around 35 to 45 minutes. That'll take us to the top of the hour or a little bit before that. And then we'll open up to question and answer. And yeah, my presentation will be broken up into 3 parts. The first part will be talking about groundwater and aquifers in general. And the second part will be focused more on the recharge mapping project, the groundwater recharge mapping project that has been completed this year. And then the last part of my presentation will speak to saltwater intrusion and some resources for well owners on how to mitigate saltwater intrusion risk and throughout my presentation, I hope that I am providing some resources for best practices and best management practices around groundwater and using groundwater wells. There's a fair amount of resources that I have within the presentation. And so some of those resources, of course, you can just search on your own, but we'll also be providing a reference list as part of the frequently asked questions that we'll be posting following these webinars on the website. Yeah, so without further ado, I'm going to get right into it because there's a lot to cover. So groundwater is a unique amenity in the Islands Trust area. I have been steadfast in bringing this forward time and time again as from a hydrogeological, from a scientific perspective. Groundwater is unique on the islands compared to elsewhere in British Columbia and in the lower mainland in the interior. All the groundwater on the islands comes from meteoric water. And what that is meteoric water relates to precipitation. So rain, snow, and fog provide all the essential fresh water for island life. We don't have a consistent snowpack that provides water from year to year. Obviously, we don't have glaciers on our island, and there's no off-island imports of water except on BC ferries or on a barge. And we'll get to that. I'll lead off my question and answer period on why groundwater on the island, fresh water on the island doesn't come from Mount Baker, which is a myth. The Islands Trust freshwater sustainability strategy is comprised of goals and actions, and those actions are framed around certain programs. And one of the programs is the Groundwater Sustainability Science Program. And the material that I'll be presenting on to you today addresses several of these actions within the strategy. It's the part of the strategy that has received the most attention in the last 4 or 5 years, and we'll continue to work on groundwater actions as they relate to the organization and as we have capacity to do so. And if again, I'm not going to belabor the strategy. This probably be one of the last times I talk about it. And so if you are interested in that, you can review the last webinar and also read the strategy, which is on our website. Okay, so the first project that I'll talk about is the Aquifer Conceptualization Project, and it's just a fancy word for trying to understand what aquifers are and trying to structure our knowledge and data to further investigate the aquifers across the Islands Trust area. So what is an aquifer? The textbook definition is a subterranean geological unit that can store and transmit water in useful quantities for domestic, industrial, and ecological use. So on the islands is their unique geology? And the answer is yes. Island aquifers are unique since technically they're considered catchment basins that intercept precipitation and store them and then provide them, rather than extensive layered geological stacks like there is in the interior of British Columbia or in the Western Canadian Sedimentary Basin underneath the prairies in Alberta and Saskatchewan and Manitoba. For the majority of the islands, they're isolated formations of geological material, and I hope that some of the materials that I'll be presenting in the next slides help demonstrate that. And so some of these images here are from, oh, I forgot that there's an error there. So some of these images are borrowed from elsewhere, from either resource material or the internet. But these beautiful hand drawing images are from one of our planners, Phil Testamel, who worked with myself and other staff to try to convey the story of groundwater in the Islands Trust area. And this is a really good example of a part of an island. For me, this kind of looks like looking at the tip of an island, like say the northern tip of Galliano, and taking a slice out of it and looking into the island. And here you can see that there's ocean water on either side of this bedrock spine that indeed is connected underneath the ocean. That there's several fractures within the bedrock that fills with water eventually. And we will be talking about the role of saltwater intrusion later in this presentation. But as you can see here, that there's very limited pathways for water to travel from elsewhere and to make it through all this salty water and magically come into the island and be fresh again. There's many physical reasons why that doesn't happen. And some of those that I'll talk about when we discuss saltwater intrusion. But truly, if you look at this, we can have a sense that we are on an island, and the water that is associated with that island is not only special to that island, but is derived from it. So another interesting difference from the islands compared to, say, larger centers on the coast of Victoria and Duncan and Nanaimo and Vancouver is the majority of the water source for those communities is sourced from lands that are set aside for the particular use of generating water in watersheds that are protected. But as you can see here on the islands, that we live and recreate and we work within our watersheds, and there, to reach sustainability, there needs to be a symbiotic relationship between the lifestyle of our community and the ecological health of the watersheds. And all that is integrated with groundwater resources. One of the confusing aspects of an aquifer, and I get this a lot, I have many people ask me, can we have the maps of the aquifers? How are we mapping the aquifers is a question I get a lot. And from the technical definition of a geological unit, the province who undertakes the aquifer mapping largely sees these islands as larger basins. And for example, Galliano Island is mapped as one aquifer, aquifer 320, although it does contain several geological formations. As you can see here, this lighter one here is called the Gabriola Formation, and the Spray Formation and the Joffrey. And those names might be familiar to you if you understand geology of the island that you live on. it is widespread in the Southern Gulf Islands, but also it's the same geology that makes up Denman and Hornby. It's part of it's called the Nanaimo lowlands, including Gabriola, of course, and the islands in between. I don't want to leave anybody out. And so this can lead to some confusion. So the one take home that I want to leave with you around aquifer mapping is that it is a very regional, high level designation of groundwater resources. And there's other methods to defining areas of an aquifer to understand certain locations better. Because I mean, as you may like envision that even though it is one basin aquifer, likely the behavior and the water resources of wells on the furthest northern tip of Galion Island are somewhat disconnected from the groundwater resources and the water use and the issues on the furthest southern tip of Galiano Island. Here's another. I'm just going to go through kind of I'm going to step through a cross section of a aquifer, and we're going to be looking at Denman Island here. And just to explain a cross section, I use them a lot. Hydrogeology is one of the main ways to describe the subsurface is a cross section, and this in the simplest terms, a cross section is looking at a landscape and taking a slice through it like you would a slice of cake. And like my image earlier of the geological cake, it's looking at it in the side view. So here, if you can imagine, we're going to take a slice through Denman Island here, almost right through town and through the village, and we're going to be looking at it if we're standing in the middle of the island here and looking north. That's what we're seeing in this cross section, which is located on the top of the screen here. And so you can see there's a big A and a big B, and so this is the A side and that's the B side. And this is the profile of the island. I hope you can see my hand. I'm just guessing you can. This blue line here is sea level. And you can see there's a group of wells here, and that's the wells that are near the village. And there's a group of wells here, which when you come over the escarpment, and then over here on this side of the island is another aquifer. And this is one of the rare cases where in the Islands Trust area where you have aquifers on top of aquifers, which is quite common in interior BC and in Alberta. On the islands, it's quite uncommon. And this particular aquifer is a quite famous one. It's called the Quadra Sands Aquifer or Quadra Sediments Aquifer, depending on who you ask. And it's quite prolific in the on the main island in say the Black Creek Merville area. The majority of the water resources come from this Quadra Sands, and so there's a quite large extent of it on the what is that, the eastern side of the island there. And yeah, I think another thing that I would like to comment on is that these horizons here are different geological formations, and they will outcrop on the surface here. So if you're walking around the village on Denman Island, you'll be walking on top of the Cedar District formation. And as you see, as we move to the interior of the island, that geological unit is dipping below the geological formation, the De Courcy formation here, that is on the surface. And so with these groundwater wells here, you can see that in town, the Cedar District is providing water. There's groundwater wells there. And on top of the escarpment here, the drillers went through the DeCourcy Formation and then eventually went into the Cedar District Formation. They had to drill deep to get there. Yeah, and so this is this whole package here is considered one bedrock aquifer, and this quadrus sediments, which is called an unconsolidated aquifer, meaning that the sediments aren't glued together. They're not made into rock yet. They're like sand. You can dig into them, and it's like a sandbox. And that's aquifer 739 and sits on top of it. I believe that this aquifer is 740. And so I just want to show another example of how interesting and powerful these visualizations can be, these conceptualizations of aquifers. And we're going to zoom in and see something really unique about the Quadra sediment aquifer here. So continue to my next slide. So this is part of a project that we did through the Aquifer Conceptualization Project. We partnered with the province, with hydrogeologists there, and they wanted our consultant, GW Solutions, to remap this Quadra Sands aquifer, which in the past has not been mapped. It was just missing. It just showed bedrock aquifer here, even though it was known that there is quite a thickness of sediment. And as you can see here, this plan image or plan map on the left of your screen is showing the thickness of the sediments there. And so the blue is less than 5 meters up to 20 meters in red there, which is quite a significant amount of sand. And yeah, I think what I'll do is I'll just continue on. So there's a line here, again, an A to B line, which is going to be another cross section. So this is a much smaller cross section than we saw before. So the scale of the cross section is going to be more exaggerated. And here we can see that there's these quadrus sediments, which are sand, and then there's drift sediments underneath, which is a harder clay or a glacial till, which is somewhat of an impermeable layer. So it acts as a floor to the aquifer, if you will. And I'm just going to roll over to the next slide here. So here's a really interesting scenario. So in the summertime, groundwater, it hasn't rained for say significantly for several months, and so these are groundwater wells that are drilled into the sediments, and they are, this is an entire screen. So essentially any water can just make its way into the well and get used. So in the summertime, there's groundwater use from the wells. It's always leaking out into the ocean in this scenario. There's also, this landscape is not barren. There's vegetation, and in the summertime, it's utilizing water. So in the summertime, the groundwater levels in this this sediment package are quite low. So the gradient here is showing, so water likes to move from high to low, and that's the same with groundwater. So here that there's a higher groundwater level in the interior of the island, and a lower groundwater level near the ocean. So the water will flow through the ground, like through the sand, and it'll exit out of the cliff here. And I'm sure if you explore the beaches, or if you're on kayaks or boats, and if you look to these beautiful bluffs on the islands, you'll see either water leaking out in more bedrock examples. Since there's more dissolved minerals and things like that, you might see white staining or red staining on that look horizontal, and that's from prolonged and consistent groundwater seepage or springs. The really interesting thing about this scenario is the relation to Little George Creek here. And it's an interior creek that eventually makes it to the ocean. And in the summertime, the creek is likely going to dry up. I have to admit, I'm not too certain of the hydrology of this particular creek, but from the scenario, it seems like it would dry up. But from the gradient, the water wants to flow from the interior of the island and then exit the island. In the wintertime, when there's a lot of rain that's getting deposited on the north part of Denman Island, and these sediments are quite permeable, meaning that the water can percolate down through the sediments quite easily, especially in this area where these sediments are open to the atmosphere. This Vashon drift here, again, is like a clayey, material that can either deflect rain or slow its propagation into the subsurface here. And this aquifer starts filling up with water. And the interesting thing about that is that it follows the topography once it's filling up. And that will then allow the water. I don't know why these are pointing downward. They're supposed to be pointing towards Little George Creek here, because the flow of the groundwater, it goes from high to low. So from here, it will go down, but it's also going to flow towards the creek. Yeah, that's an error. These should be pointing this way. And so in the wintertime, the creek will be receiving groundwater, where in the summertime, if there is any flow in the creek, it will be providing groundwater to the aquifer. And that's a very unique and very important relationship to understand, is the relationship between groundwater and groundwater use and surface water, and of course the ecosystems that are associated with surface water. Indeed, there's still flow that moves out to the coast in the wintertime. But yeah, this is a very unique scenario. And part of this project that we did, this aquifer conceptualization project, this is particular to Denman and Hornby, is we were looking to see which streams would be either gaining water from groundwater or losing surface water to groundwater. And yeah, as you can see here, this is that area, the aquifer 739, and I believe this is Little George Creek here. And so for the most part, it's a gaining stream. It's likely not considered a losing stream because there's little flow in the summertime to be losing that water to the aquifer. And if there was, it would just promote it to stop running quicker. Yeah, and then it was suggested that further down in the system, it becomes a non-connected stream. So it's just that it's not gaining or losing groundwater. So very unique outcome from undertaking the aquifer conceptualization project. And yeah, and this is very important for the health of aquatic systems, and especially salmon bearing streams. And when there is an application for to use water, either surface water or groundwater for non-domestic uses, groundwater surface water interactions are and environmental flow needs are considered deeply by the province in their adjudication of that application. To go back to the statement of Galiano being one gigantic the actual technical geological term is massive. A massive aquifer is to look at it in a different way. And groundwater regions are this intermediate scale regional approach to organizing the thought process around water management on these island aquifers. And the groundwater regions on Galiano, I think they were probably the first to be established. They've been around since the 70s, and you can see that I think there's like 17 of them. Here's like the North Trincomalee Channel and North Georgia Strait, and all of these are there's no really true defining feature on the landscape, but they are generated based on certain criteria. And that criteria is like defining groundwater regions from previous studies. So this is part of our project where we looked at historical reports that perhaps describe a groundwater region. We considered new watershed mapping, new topography data, water well concentration zone. So if there's a particular region where there's a very concentrated neighborhood, then that might be delineated as its own groundwater region. It does depend upon geology, and then also mapped aquifers on other islands like Salt Spring Island. There's several aquifers, and so those aquifer boundaries, which are largely defined by geology, will likely define a groundwater region boundary as well. And this is the Gabriola region here. So moving on from that, sorry, we're just going to jump right into what provides us groundwater in our homes and as an industry, in agriculture, and it's a well, of course, and yeah, and a well essentially provides us access to stored water underground. And there's several types of wells. The most common in the Island Trust area is drilled wells into fractured bedrock. And here's a well. This is being drilled in somewhere in the Northeast BC, and here it's actually artesian, so the water is just coming right out of the ground under pressure. Here's a typical profile of a groundwater well. Although this is not completely true, where this shows a water level here and seems like this entire area is saturated. This is not particularly true because in a fractured aquifer, the water is actually contained to the open fractures. The rest of the rock is just rock. So I would take this drawing for a grain of salt. This is from the groundwater handbook, which I'll provide a reference to. And this is what a groundwater well looks like, this photo on the right. And this is taken from, if you know him, Mike Way. He's a famous hydrogeologist on the coast here, and had a storied career with the province of BC, and now is on his own consulting and hydrogeologic. And this is a really great blog here, domestic groundwater use in BC, and I encourage you to read it. And this photo is from it with his daughter there, who I think this is like a 10-year-old photo. So she must be much older now. And here is another example of how we access groundwater, and it's called a dug well. So it says what it does, what it says on the tin. It's a dug hole in the ground, and often it's constructed with some type of permeable material on the bottom. And it's an open hole, and usually cased with either cement and sometimes metal. If it's corrugated metal, there's some issues with that because galvanized metal has a lot of zinc in it, and so that's been a problem for some water resources on the Islands Trust area. But yeah, and then it's like backfilled either with the same material or some type of impermeable material like bentonite or something like that, or clay. There's a really good best management practices for dug wells. So if you have a shallow dug well, I would strongly advise you to read this best management practice. The Groundwater Protection Handbook is a invaluable tool for not only understanding best practices for groundwater wells, but also understanding the groundwater protection regulation, and which is a regulation under the Water Sustainability Act. And yeah, I would encourage you to take a look at it if you find this interesting. For example, it gives a well siting guidelines in an illustrative way. It's a great resource. Another great resource is the groundwater wells and aquifers search. So you can search for any registered well in the province. When you look up a well, I just looked up the community well here on Hornby Island. It may give you details, or it may not. It depends on the quality of the data. The majority of the data comes in the form of these drill records here. So this is actually quite a good one. This was the owner of this well is the province of BC. I believe this is the observation well on Hornby Island. So it's not the same well. I just chose a different one nearby. And you can see that it talks about geology and how deep the well is down here, and if it was providing, how much water is providing, and if there is any type of fractures, where the fractures are, a whole host of information, including the location. So if you find interest in that, you can just search through the map and look at wells. The well records tell us as researchers and regulators a great deal. By processing over 20,000 groundwater well records in the Islands Trust area, we are able to help map the aquifers and generate three-dimensional groundwater models. Also look at well density. So this is an image of Bowen Island, and the Islands Trust area has some of the highest density of wells in the province. And you can see here that some of these areas are up to 50 wells per square kilometer, which is high to very high for well density. The well record, this is also another cross section, a slice through the earth again. The well records, by using machine learning and processing these data and trying to relate the driller's logs to actual geological information and identify where fractures are from, we're able to start to understand where water is coming from and in what fractures and how wells are related to each other. For the most part, it seems like drilling wells in the Islands Trust area is just like a crapshoot. It seems like it's just chaos. But what we're learning is that yes, that it is quite complicated, but by undertaking this processing of these large amounts of data, we're starting to refine a better picture of groundwater. Another way to do so is to monitor groundwater. So this is from a monitoring program on Salt Spring Island. So here's a very old well that has on the left here, that has a pump in it. And I have a data logger, which is this thing here, which measures groundwater level in the well, and every 5 or 10 minutes. And here I'm downloading a data logger with a nice view by a lake. And here's just like a stylized idea of a data logger that's sitting in the water level, or sorry, in the water column, and essentially just looking at recording as the water level is going up and down. And so what can that tell us? So this is from the Provincial Observation Wells Network. This is from a well on Salt Spring Island. And you can see here, this blue layer here is the current year, and that current year was 2018, 2019. So I apologize the lateness on this, but the reason why I chose this, it was a drought year. And the blue shading here is the range of the daily range of the maximum and minimum in that day historically from over 4 years, the length of the operating of this particular well. And the green is the historical average. And so you can see in this particular year, the groundwater level was much lower than historical. And here the scale is in meters below surface, so the groundwater is lower there, which can give us a lot of insight to the behavior of the aquifer in that area and perhaps the long-term trend of those wells. Another interesting part of the salt spring work that I was doing, and there's no scale in here, and I understand that this is just for a stylized investigation, and these two squiggly lines here are not the same scale. This squiggly line here is the Fulford tidal predictions that I took from the government website, and this is like on the scale of, I don't know, maybe a meter. And here is a well that I'm monitoring near the coast, and you can see that the well is following the trend of the tide. So as the tide rolls into the harbor, it's pushing water onto the island, and that's pressuring up the aquifer. And then as the tide rolls out, the aquifer pressure goes down, and there's this almost immediate response to the two, which is really unique. And the reason why I want to bring this up is that looking at groundwater monitoring and monitoring these different regions of the island, that it seems like every well has its own story to tell, and there's quite unique dynamics in an aquifer in any given island. So it's hard to say if an entire island is say experiencing groundwater drought at any given time, because there could be some areas that are and some areas that aren't, due to a myriad of reasons, from land use to type of vegetation to how many wells are in the region to the recharge potential. And so we'll be talking about that next. One last, and so we're making pretty good time here. The one last thing I want to show about the Aquifer Conceptualization Project is the 3D models that we generated. So this is one of Salt Spring Island, and this is just an example of how we constructed these models. So here's a cross-section by Dr. Hugh Greenwood from some geological mapping that he did. And so he took that cross-section and assigned the geology to it, including using the groundwater wells to calibrate the model. And yeah, there's some really interesting things in here. The name Salt Spring comes from saline groundwater that comes out of the ground in the northern part of the island here. And if I remove this top map here, you can see that there's this odd thing going on here where the geology is quite abrupt, and that's called a fault right in here. And so what's happening is the groundwater, it is disrupted from its regular flow path and flows along this fault and then moves to this part of the island here. And since this groundwater is sourced way down inside the island, over a long period of time, it's collected minerals, and as it slowly flows through the ground over thousands of years, and finally makes its way to the surface by getting forced through this fracture and creating a salt spring. And so you can kind of see it on here. Yeah, it's really interesting. And these 3D models are there'll be more time to explain them and to give orientation around how to use them, but they will be accessible to the public to explore. So I just want to take the opportunity to show just a few more here. So this is Gabriel Island. It's hard to see because I haven't laid over any maps yet. This is just geology. But what I'm going to do is I have a slice here. Let's see if I have it still. Yeah, okay. So these black dots here are the top of wells, and these wells are going into the ground, and they're quite transparent. You can kind of see them going into the ground because I made the geology transparent. And so what I'm going to do is I'm going to slice the island, not in a cross section, but slice the top off. And I want you to look at a few of these wells in the area, and I'll just annotate them as we go. So I'm slicing off the top of the island. So I just took off like the highest part of the island there. And yeah, okay. So I'm just going to go through this animation and I'm going to step back. So I just sliced the island down. I'm going to keep slicing it till I get to to the bottom of the island where you can't see any more groundwater wells. So let me build the island back up again. And my point here is just to show why it's confusing where if you drill a groundwater well in on one side of a property or your neighbor's property and you drill a groundwater well at the same depth like on the other side of your property, your neighbor's property, why it may or may not get water and why it might be a different type of geology. And this is the point. So the geology is not horizontal. It's on angle, like I was showing you in the cross sections. And as we cut through the landscape here, you can see there's two wells here. And so this one is still it is going to be drilled into this green horizon here, and this one looks like it's drilled into this beige horizon, but it's not. They're actually drilled into the same horizon here, but this one is actually drilled into the brown below it because it's just a little bit deeper. But you can see on how these are all different steps of elevation as I am clicking through them. And at this point here, at the same depth, there is a different geological horizon for a neighboring like landowner compared to its neighbor. And I just find that just such a powerful visualization to use to try to understand the three-dimensional nature of groundwater. And one last one I want to do is this is a another example of a cross section. So this is Hornby Island. And again, I don't have imagery on this, so forgive me. This is the big mountain on Hornby. This is Halliwell over here and Tribune Bay and Little Trib. And the one thing I just want to show with this is that when we look at the cross section on axis here, so we're looking at the slice, all of these pipes in the ground here are groundwater wells, and this is sea level here. So you can see on Hornby that the majority of groundwater wells are below sea level, which is really interesting. Um, and also here, this is Sandpiper here, and you can see the amount of wells that are located within Sandpiper. I can spend all day on this and talk about it and get into it, but we're running out of time to do that. So I'm going to move on. Okay, get back to my. So the next project I'm going to talk to you is the groundwater recharge mapping project. And so what is recharge? Recharge is the groundwater essentially flows from upland areas and into the island and flows towards discharge areas. And discharge areas are areas where groundwater is going from the subsurface and exiting out into the landscape. And this is quite a simplified idea of recharge. But one of the good examples, this is Bowen Island. One of the good examples that I enjoy about this stylized diagram is looking at Josephine Lake. So Josephine Lake is an elevated lake. It's located in the highlands, and what occurs? And I just had chance to visit Josephine Lake in December, which I was very grateful for, to see this actually in action. And it's true. So there's several like wetlands and topography around Josephine Lake that allows water to flow from the landscape and into the lake. So it's a discharge area. Water is flowing off these little ledges here and through the wetlands and into Josephine Lake. However, over time, since Josephine Lake is a body of water and it's elevated above the landscape, over time it provides a consistent, it's called a positive head boundary, a consistent amount of water that can have the ability to percolate into the ground and recharge the aquifer. And of course, this is not how water flows within the ground. There's all fractures and stuff, but this is a stylized motion of how water would flow through the fractures and eventually out into the discharge area. And so these elevated lakes and wetlands and headwaters of watersheds are so valuable to consistently allowing water to enter the groundwater system. Our groundwater mapping methodology is it looks complex, and it's pretty complex, but really what we broke it down to is looking at the role of vegetation and the role of geology, the role of how the islands are constructed, their topography, and overall to understand how much water potentially enters the ground during a precipitation event. And so ecosystems play a significant role in this. And this was a novel concept in the way that we approached recharge mapping, is that we took a serious look at how not only vegetation intercepts water and puts it back into the atmosphere, but how it also promotes the recharge through its root zone and through like stem flow as water gathers on trees and how it flows into the ground. This was a very important concept that we integrated into our model. And yeah, healthy forests act like sponges. When sponges are a little bit like moist, the ability of them to absorb more water is greater than dry, parched sponges where water just tends to hit it and roll off of it. And so this is a great drawing that Phil did for us to demonstrate that. So there's just a few maps associated with this, and I'm not going to belabor that. This is Main Island, and there's certain areas on the island where water is not retained as well. So on rocky peninsulas, water tends to not be retained, just runs off, compared to agricultural areas or forest areas where water is retained more. And so that's part of the story. Another part of the story is slope. And so areas with very steep slopes, the water doesn't have a chance to settle and to work its way into the ground. So that's in the red here. That's lower amount of recharge potential compared to flat areas, open farmland, things like that. Even though there's grasses there that can intercept water and transpire into the atmosphere, flat-lying areas promote recharge a lot more, especially flat areas at elevation. Those are like prime recharge areas with respect to slope. Excuse me. Not all areas on the island will recharge water. So there are areas where water is actively discharging, like I mentioned before. So these can be like wetlands or lakes or springs. And in this case here, they're the dark blue. But what we found was the majority, and this is through using satellite imagery, looking at vegetation and seeking out aquatic vegetation versus non-aquatic vegetation. And indeed, the majority of the island area does promote recharge over discharge. And for example, that's the opposite, say, in the northeastern part of Alberta. I mean, there's just so much discharge and so many wetlands and bogs everywhere. Where that's not the case on the islands. It's mostly well drained and promoting recharge areas. So this is the relationship between recharge and discharge, where the red uh, is discharge area, and the blue and the green is promoting recharge. And so, yeah, we ended up getting a recharge potential map, and this is just raw data, where the dark blue is where where precipitation really wants to get into the ground and to make its way into the aquifer, where the yellow values are discharge areas or where recharge isn't happening. So what are some examples that we can use this recharge data for? We can classify the recharge data. So this is Bowen Island. So we're looking at an image here that's blown up. So this is Josephine Lake again, and we have classified the recharge from moderate to high to very high from that raw data. And the way that we did that, this looks quite complicated, but it's not really. We just did a statistical analysis of the data to then classify high and very high. So it's just a statistical method. So it wasn't like anything subjective. Yeah, I'm just not going to talk about that one. Well, yeah, actually I will. So what can we do with this recharge data? So we can try to promote the protection of recharge, and how can we do that? It can be through something like a development permit area. So this is a project in process. This is not a development permit area on Galiano Island. It's a project that is still open and working its way through the process. But what the idea was to understand how much recharge is located on a particular parcel. On any given lot on Galiano Island, we have determined how much like high to very high, which we're calling critical aquifer recharge, is on a particular parcel. And here's the options that we offered to the local trust committee were to consider to put inside a protected area like a development permit area if any given parcel has 2 hectares of recharge to 5 to 10 to 20. And you can see that with 2 hectares of recharge on a particular parcel, the parcels affected are quite large, where 20 acres of or 20 hectares of aquifer recharges is lower. So yeah, I think like I'm going to move on from this, just because this is what I'm moving into question and answer period. This is a very interesting project. I encourage you to look at my staff report on the Galiano Island website if you want to learn more about this, but I just have to move on because we're running out of time. One other aspect of using groundwater recharge is to determine the amount of groundwater availability and for determining island water balance. And so here we can see that in a water balance scenario, we're trying to understand on a small groundwater region here how much precipitation is put onto the landscape, and actual evapotranspiration. This is how much the plants are either using or transpiring or evaporating back into the atmosphere, and what's left over. And after it rains and after the plants use their water, there's a certain amount of surplus, or what's water is left to use, and this is annually. The majority of that water runs off in any given context. And the amount of groundwater recharge left from this massive amount of, this is in millions of liters, so 2,000 million liters, 20 billion, 2 billion. Yeah, 2 billion liters of water. There's a small fraction of it left. And so we're trying to understand how much is being used, and that's all we have left to kind of share in when we're looking at water balance. So my ending slide here is just to describe on how essential it was for us to determine this groundwater recharge potential across the Islands Trust area. And now we have that data to now implement into some significant studies on understanding how much water is available and to try to truly understand water balance and strive towards freshwater sustainability. And all the things that I spoke to, from aquifer conceptualization to the recharge, is trying to trend towards understanding that. My last few slides here, I just want to talk about the risk of seawater intrusion. So our islands are surrounded by the ocean, and underneath our islands, through precipitation and rainfall and then recharge, there's a fresh water that is below our feet. And as I showed, the groundwater wells are largely below the sea level, as we can see here, but it's mostly fresh water below there. Where there's sea around us, that seawater is quite dense, and that seawater is making its way out of the open water and into the geology, and creating this saline groundwater like moat around all the islands. And so here's another image of it where fresh water will go into the ground and try to, and under the forces of gravity, it'll push its way towards the sea. And then the seawater, under the forces of density, will make its way into the ground here and create salty groundwater. So you have this transition or interface between freshwater and salty water. And so Phil made a really good diagram here of how this looks in a fracture environment, where this salty seawater can make its way into the fractures, and it's possible that that water can push its way into the fracture and towards groundwater wells here that are advanced into, which historically those fractures were supported by fresh water that's being recharged through this chaotic network of fractures. And there's many influences on why that will happen. One of them is sea level rise. So as the sea level is rising here, as you can see by this line here, it'll slowly push that saltwater interface into the island, more so than if it was not rising. Yeah, so I'll leave it at that. Island Trust was involved in mapping of seawater intrusion, and this will be you can read this article, but essentially it's looking at it's describing areas where there's a susceptibility to saltwater intrusion, where like a risk rating of 5 is high and 1 is low. And here's just like a zoomed in version of Ganges Harbor and Fulford Harbor on Salt Spring. And you can see along the estuary here that the rating is 4, which is really high. Like that is a significant risk of saltwater intrusion in those areas. And so we're using mapping data to understand areas that can be at risk of saltwater intrusion. And so what can you do if you live on the coast, or if you feel like you're at risk of saltwater intrusion? There's this best management practice for prevention of saltwater intrusion, and it gives a good list of all these considerations to protect your well against saltwater intrusion, including like where you site your well, how deep, how much, if you can reduce your pumping rate or reduce your pump depth. Yeah, it's a really good resource in determining into helping well owners with that risk. So yeah, I'll leave it at that. I know that I ran a little bit over time, but thank you for your time, and it's a lot of information, I know. And yeah, let's move on to the question and answer, and feel free to ask a question here or contact me at my email address at freshwater@islandstrust.bc.ca. Thank you.
Awesome. Thanks, William. We received quite a few questions throughout the presentation, and we'll do our best to answer them. And as I mentioned at the beginning of the presentation, if we don't answer them, we'll do our best to answer them maybe in a, we'll answer them and put them on the website so you can take a look there. I'm just going to share my screen. So William, can you stop sharing your screen?
Oh, yeah, of course.
Thanks.
Yep.
All right, so remember these are in order, so and we have 13 on this page, and then I will do my best to copy and paste other ones to another PowerPoint, so you can always see the question on screen. So there you go, there's your first one. Hopefully you can see it. Can you see it?
Yeah, I mean,
no.
Oh, no,
Wait,
I just took
sorry.
it.
Could you, sorry, I was worried that maybe you didn't see it properly. So there we go. Okay, you're seeing the screen, the PowerPoint?
Yeah, I see it, yeah.
Okay, thank you.
Yeah, I think I spoke to this in my presentation about the different, like, around groundwater levels in the unconsolidated sediments to where I was showing the groundwater monitoring where each well can tell its own story. There is a depth to water map of Denman Island that we'll be hosting on the Freshwater Atlas. And so that also will allow you to kind of explore the patterns of groundwater in Denman. Just as a rule of thumb across the Island Trust area, wells that are elevated, that have elevation, that are in the highlands, will have a significant change in from winter water level to summer water level, much more so than wells that are closer towards the ocean, which will have a subdued change from winter to summer level.
All right, question 2.
That's a good way to do it.
Yeah, this is question 2. There was 4 parts to this question, but I put 2 on a page. Yeah.
Yeah, so we're already using the groundwater recharge work in several in several projects, including the one that I regret that I didn't have time to talk about a potential development permit area, but also it's used in vulnerability assessments. It was used in the main not affordable housing, but alternative housing study. Can we quantify that there is a high likelihood of larger areas seasonal? The only way to do that is water balance. And so that's the answer for question B there. Yeah.
Okay.
That'll determine the likelihood of that.
Okay, I can go on to the next one.
Yep.
Okay. Okay.
Impossible to do them for all island watersheds. I think the reason why Weston or Lake Weston, that there's a particular ask there on can Lake Weston through the Fulford Water District be expanded, and that's what drove that water budget. And so we have been looking at islands that have particular housing projects right now that would vastly benefit from a water budget. And currently for next year's budget cycle, there is a budget request to do water balance assessment on Gabriel Island. Next one.
Okay, thank you. Oop, there you go. Longer one.
Yeah. Of course, like there's going to be a holistic methodology developed for a water balance study. The groundwater availability assessments that were done in the Southern Gulf Islands through the Islands Trust were like preliminary regional assessments, and the Lake Weston water balances assessment is a really good example of how those data were integrated. Next question. Yeah, this is related to Salt Spring Island freshwater catalog, and again, they were integrated into the Lake Weston project, so you can investigate those. Yeah, on the ground investigations of stream flow is truly beneficial for water balance assessments. That's why staff identified Gabriel Island as a really good candidate from the long-term monitoring of groundwater wells from the Regional District of Nanaimo's Drinking Water and Watershed Protection Program, as well as the stream keepers work up there. That there is a rich amount of data to undertake a water balance and nail down a really good methodology for that, and that would then be beneficial to other islands that undertake similar work. Next question. Well, pump tests happen all the time. Late summer is not when groundwater drought is. Groundwater drought is usually in in kind of mid autumn. There's a delay of when the rainy season starts. There's a delay in when the recharge starts happening, especially in the highlands. So yeah, pumping tests that are conducted in October and like late September, October, and early November are usually when water levels are lowest. But pumping tests are really meant to determine the efficiency of a well rather than to truly investigate the regional characteristics of the aquifer. That's really can only happen through long-term monitoring and modeling like I described. And so the efficiency of wells don't change that greatly from when water levels are lowest to when they're highest. So although it's best practices to conduct a pump test during the lowest period in case they're like that to see the lowest limit of the drawdown during a pump test, they happen all the time. But best practices are to do it during low water periods, which is in the mid-fall. Thanks. Next question. This is a weird question because building permits are from the regional district, and so like this question is an odd one. So Islands Trust is involved in rezoning applications and subdivision, and in those contexts, there needs to be a proof of water. Subdivision is proof of water through the land use bylaw. Rezoning applications have stringent water assessments, especially if there's a application for a groundwater license. And through that, like there has been some groundwater applications on particular on Main Island where a full water balance or water budget was done just for that one particular well. And so that then identified neighboring wells and recharge and the water demand of that particular development. And so it's not the developer hires a hydrogeologist. And in that context, the hydrogeologist did a full-blown water balance assessment, including a climate change analysis. So it does occur, especially during rezoning for building permits. I don't know. It's not in my jurisdiction. That's the jurisdiction of the regional district.
All right, next one is this guy.
Well, were they purchased? Well, yeah, maybe. I think so. They're protected areas. Are there other watersheds protected? Well, there's protection measures on watersheds in the Islands Trust area on Salt Spring Island. There's watershed zoning and there's development permit areas on riparian areas. I am unaware of watersheds in the Islands Trust area that are fenced off, and you'll get like kindly escorted, or even, I don't know if they'll take you to jail if you go into the Victoria one, but yeah, I'm not sure about that question. I don't know if they were purchased. I think Victoria did purchase the Leech River watershed. Uh, I don't know that history though. Good question. We'll look it up.
Next one.
Don't know yet. That is the essence of the water budget. So I don't know the answer to that yet.
Okay, next one.
Well, oh yeah. So those wells that were in Aquifer 739, that was the particular unconsolidated section. So in that part of the island, yes, like that's where there is a good water resource, and often when there's a good water resource, there's not a incentive for a well owner to drill beyond that one and to go into the bedrock that's below 739. So the unconsolidated aquifer sits on top of the bedrock. But since that unconsolidated aquifer, that sands and gravels and stuff, provides enough water for their use, that's where the wells are. And so I think there's other wells in that area that are advanced into the deeper bedrock aquifer there, but just through experience, it seems like the bedrock aquifer pushing towards the northern part of Denman Island is not as good of water quality as other areas of that island. So that's why 739 is used quite significantly in that part of the island. Next question. Good question. Ooh. Yeah, it has to be that'll be a case by case basis. Can't make a comment on that.
Okay, next one.
Yeah, so well density is a good one. So it is a good proxy for understanding if there's going to be a area of um of water issue. It's actually the other way around. We know that there's water issues in areas of high well density. So by undertaking the well density study, it's just kind of explaining or providing some backing to what we already know. And so what well density will do in a more robust water balance assessment is that we'll start to understand what's the water demand of those wells, and then that, so say for a particular area, perhaps a well density of 20 wells per square kilometer, there's more water use there than another area with the same amount of density, or if they're equal, it's possible that one well density, that 20 wells per square kilometer, has better recharge potential compared to a neighboring groundwater region that has the same density with less groundwater potential. So then that area will have a more vulnerable water balance. And so that's where that's where well density plays into it. It's one of the main components of undertaking a holistic water balance assessment. Yeah, great question. Next question.
Okay.
Ooh. So the problem with aging groundwater on the islands is, it's a very good question. Is that it's a very leaky system. So if you drill a well into the ground, you're going to go through all these little micro fractures before perhaps you get into a larger fracture. And so to try to date that, like through isotopes, is very difficult. You kind of have to have this particular drilling technique where you isolate off all the fractures and try to find that one fracture you're trying to date. Really difficult. There's other dating techniques, like looking at tritium isotopes and things like that, it, it's very difficult to age water particularly. However, a proxy for age is looking at total dissolved solids, which is the hardness of your water. So if you have really hard water and there's a lot of minerals in your water and even there's even salty groundwater, that's really old water. So if you have water that has, say, 1,000 parts per million of total dissolved solids, which is quite a bit. That's like mineral water. That's old water compared to groundwater that has maybe 60 parts per million and it's like Dasani, right? Like that's the real soft water. That's gonna be really young water. So there are some proxies to understanding how old groundwater is, but like direct aging is really difficult. There's some work done on it, but my question with that is why? You know, like aside from being very interesting, how does that relate to water balance and our understanding of how water relates to ecosystems and humans is I think it's more on the want to know rather than need to know. Next question.
I think that's yeah, that's this
Oh, that's
PowerPoint.
all.
No,
Oh,
no, 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 no.
I
There's
was
more.
getting
Just 1 second.
excited. There's a few more.
There's a few more. Hold on. I just have to make it bigger.
Oh yeah, okay. This is a
Oh,
good one.
sorry.
Oh,
Just 1
that's
second.
good. Ah.
Okay, you can see it though. Okay.
It's good. Yeah, it's good. Yeah, we can see it.
Okay.
Does Cushion Lake replenish groundwater in the dry summer months, or does the groundwater flow into Cushion Lake? Great question. And my short answer is I don't particularly know. However, there's a way to investigate that by looking at what the underlying geology is of the lake. And I believe the lake transitions from a more like marine clay floor to at the end of the lake, which is a whole sand package. So it's hard to say. If I were to just hazard a guess, I would say that Cushion Lake is a flow-through lake. So it's neither donating or receiving much groundwater. It's likely going to since its location is further down in the watershed, it's likely going to receive water through discrete fractures more than offered to it, and the bottom is likely has like a lot of over time silt and all those things that kind of slow down the the percolation. But it's a great question. I don't particularly know, but yeah, it's a good one to have a coffee over and think about. Thanks for the question. I like that one.
So I do understand it's 8:29, but because we just have a few questions left, I think we're just gonna go in for another 5 minutes or so, or just so yeah. Here.
Sure, if I'm making sense though. Well, I want to read this question as the royal your, like not me. Like, how complete is the island's trust understanding through the planning service on how much development can be sustained? And I mean, I think that's been a question since 1973. In the terms of freshwater resources, uh, the the only way that we can start answering parts of this question is to monitor water resources over long periods of time. And we do have monitoring, but it obviously there's data gaps that can be filled, but to continue those monitoring programs and to do analysis on them, to determine water balance and to undertake like coupled investigations of build out analysis of like existing zoning and those things. Um, understanding the role of climate change on groundwater recharge and ecosystems and watershed resiliency, and then truly understand the wants and needs and desires of our First Nation partners who have right and title to the land. So that's a holistic question, and I'm really excited to be part of that, of trying to answer that with planning staff and the rest of Islands Trust staff, so, and our politicians too that are trying to guide us there. Good question. Oh yeah, cool question. Well, yeah, I mean, this is great. This is like where you can split hydrogeologists on the other side of the table and have really good discussions well into the night. Um, on Gabriola Island, the like the shales, the slates are highly fissile. They're really fractured by the nature of their properties. And so of course they make the fractures, and that's where the porosity is. The porosity is not in the rock. The rock is non-permeable. The majority of the porosity, well, all the porosities in the fractures, but some formations fracture more than others. However, say for like on Damon and on Gabriola, where you have these highly fractured shales, they're horizontal fractures mostly, and so it's sometimes it's difficult to recharge those fractures. Sometimes they're not really connected that well, or they're contained with sulfur and things like that. Where if you have on Salt Spring Island, some of our biggest wells are on granite, where you have a few fractures, but they're open and they're dipping vertically or somewhat vertically, and they don't collapse because they're in crystalline bedrock. And so that leads to not only the porosity is one thing, but how connected are those fractures to the recharge zone, and how they're connected to the rest of the fractures in like the storage within those formations. So yeah, great question. It's definitely a geologist who asked that, I think. uh, we don't. So okay, I have to unpack this, but how do I get data on private wells on water consumption? So we don't, unless it's offered to us. We have estimates. One of the estimates that we used in the groundwater availability assessments for the Southern Gulf Islands was 625 liters per day per dwelling. It was just a wild guess from other. Well, it wasn't a wild guess. It was using other data that was collected from other municipalities and other groundwater managed groundwater systems that need to report on their volumes, say to the province if they have that as part of their water license. And with water levels, we like unless a water well is being monitored, water levels aren't being recorded. And so yeah, those two pieces of data I'm not privy to it unless I'm collecting them myself or they're offered to me. So yeah.
Okay, I think this is the last one.
Nice. Yeah, there's tons of them on Lasqueti. Lasqueti has, I think, the highest density of water licenses on the islands for their small hydroelectric installations. I think like the Hall is still run on an old water wheel. So the need was there on Lasqueti because they're not connected to BC Hydro, so that potential was realized there.
Awesome. All right. So
So I can I follow up with my question?
yeah,
Does water on the islands come from Mount Baker? I hope through this presentation that I tried to prove that it, it it's an impossibility for fresh water to come off island because of the saline ocean water that surrounds the islands. on say in the prairies, water that's get recharged into the Rocky Mountains can travel into the ground and travel hundreds of kilometers to provide fresh drinking water to people in the interior of Alberta, into Saskatchewan, even into Manitoba. Some of these aquifers are that big. There's a potential that where there's islands that are close to mountains, like closer to the main island, like say, I don't know, Salt Spring Island or something like that, where you can have groundwater pressures that are being applied by the mountains, say on Vancouver Island. And that might cause some type of effect of the groundwater system, like in and around the islands and maybe even into the island. But it's likely an impossibility that water can be recharged off island, like say on Vancouver Island or in the Olympic Peninsula, and travel under the ocean and not get contaminated with salt. It's likely an impossibility for that water to eventually make it to an island and actually be fresh for drinking. The ocean's really salty. Yeah. So
Got
I'll
it.
leave it at that.
Okay, thanks, William. So thank you all 66 of you who have stayed around for the whole presentation. If you had asked a question and we didn't get to it, we'll do our best to answer it. And yeah, we just want to thank you all for coming and spending your Tuesday night with us. The recording, for those, I know I saw a question there about someone arriving late. Yes, this presentation is being recorded and they'll be posted to the website so you can watch it later and whatever parts you missed. And as mentioned earlier, we'll do our best to do kind of a Q&A sheet and post that to the website to some of the questions that perhaps wasn't covered, or William wants to expand on them because he thought about them a bit more, because of course he's looking at this for the first time when it's being presented in a PowerPoint. So, but anyways, thank you all for coming, and yeah, thanks for spending your Tuesday night with us.
Yeah, thank you, everybody. And yeah, feel free to send me an email